command pattern. It separates an action or a command from the object sending it and the receiver of that action or a command. Why would you ever want to do that? And what's the point of the command pattern? In a web app, we might want to call a backend, say, frequently to update some data. If we are selling some limited edition product like tickets or something that is like low on stock, something that could be sold out while the user is looking at our page still. So we need a timer that will call backend, say, every minute, and we want a button to manually check the backend when pressed. So both the timer and the button would do actually the same action. There are different triggers, but they would do the same action. And now we don't want them to interfere with each other. And this is where we separate the command from the sender or from the receiver as a separate entity. And this way, one action might have multiple senders, or the most popular use case of the command pattern is the undo functionality, because we could store the action and its consequences, and then we could just call the undo of that action, because we actually know what the action is. We have that as its own entity, right? Thus, we can revert the effect easily. And there are more reasons to use command pattern that we will go over in this course, and especially in the skill builder section. But in short, we usually have an action attached to a receiver, like the form, having a save action. And we want to invoke it from multiple different places, like the save button, the keyboard shortcut, and maybe the timer that will save some complex forms automatically after a period of time. Handling this save action activity suddenly can become a bit more complex, even if it's a simple save action, right? Especially if we want to undo a save and keep track of maybe the time and which user has invoked this save action. And if we want to have different behavior for clicking a button versus a timer when saving, and especially if we are multiple people working on the same form, the same action, you can see how it will just grow and grow without handling all those specific scenarios. And the form will be doing a lot of work that is actually not form related, thus breaking at least the single responsibility principle. And that is where separating the action from the sender and receiver gives us a lot of benefit and flexibility, because the caller of an action keeps doing their own work, they keep their own functionality, focused on what they do best. And the receiver of the action also follows a single responsibility principle. The form should only be caring about saving the data in the form, and action should care about who saved it, when it was saved, how to undo it, and whatnot. Now this is where the action becomes its own entity or an object that has some specific functionality to that action itself. We might consider design pattern when we need to run a delayed execution or scheduling. Since we have action separated, we can just store it and execute that action when needed, or even call it multiple times. Or, very good use case, if we want our application to work offline in a limited capacity, we could store all of our actions in the browser and then just execute them when the app comes online. We can just rerun them, right? We can also do a rollback, the undo functionality on failure maybe. If some complex operation fails, a big form submission, we can just roll back the changes instead of just clearing everything and frustrating our users. We can also use it when we need to log something or when we need a history. We might need to know who did what and when. If we want to show history of who created an article and who updated it, who published it, etc. And it's much easier to use one design pattern where we have control over the action itself, rather than adding that logging functionality to each and every function in our system. So the biggest benefit of a command design pattern are decoupling. We separate the objects that invokes the operation from the object that knows how to actually perform it. Flexibility, it's easy to add new commands without changing existing code. The form will still be the form, even if we add commands like save draft or undo action, because we have separated the form from that chain of command. Undo, redo functionality, this pattern is perfect for simple implementation of undoable operations. It supports batch operations. We can easily queue and execute different commands in a single or maybe in batches. thus making complex workflows when needed. But like all things in life, it has trade-offs, and like any other design pattern. The one is complexity. Since we are introducing additional layers of abstraction, we need to be certain that complexity is not just a fancy code, but an actual smart solution to our problem. Another trade-off is overhead. Because each object is now, because each command is now an object, we might end up with a lot of objects for doing maybe some simple operations. You will probably notice this in the very next lesson, so do not be scared when you see one line of code being replaced with 30 or 50 lines with an action, which might lead to a conclusion that you're never going to actually use this pattern. But stay with me, number of lines that are duplicated if action is not used is actually much more. It also has a learning curve to it. We need to have a decent understanding of object-oriented principles to implement command pattern effectively and knowing when it makes sense. Let's look at one real-life problem that a command pattern can solve, and here we have an article in a content management system which has two methods. One is to change the state of the article, and the other one is to, well, obviously save the article, right? The state changes here from drafting to review and then to publish, and the save method it just saves the article's new text. And now you can assume that there is a much more code here in each of those methods that deals with actual storing this in database, calling the backend or whatnot. For now, we're gonna keep it simple, just focusing on this command design pattern. And the problem that we have here is that we need to add handling the history of this article, especially on this save article method here. And then we are also going to log the action of saving the article itself. Now in the change state, we already have the code here for this. So it's this history push just adds the change to the stack. And if we look at the console here, when I run this, we can see that the state has changed to draft and then to review. And we can see the change log of changing the state to review and publish. That's been done here in our controller here. So it starts with the draft and then it gets to the review and to the publish, thus new states that are being pushed. So now we need to add this history version and logging activity into the save article as well. And particularly the history versions, right? So that each time we save the article, we can go back in time and see the previous version of the article, the previous text it had, and what the changes are. Well, the simplest way to make the history from the save article is to, well, just copy this history push and this console log into the save article method, where we could just change this action from state change to save article, so that we can see the history of what has happened with this article. We want our administrator to go in and see that it first was created, it was a draft, somebody changed the state, somebody updated the text, and then somebody has published it, right? So this is what this history does. So here I can just put the new article here, and I will just pass here the user as well, so that we can have this a bit uniform. If I would to run this now, I wonder what's gonna happen. We can see that the change has been went from draft to review to publish, but we can also see that there has been action of two actions for state change, right? This is the first one, this is the second one, and then the save article, which has a new article text here pushed by Bob. Now this works just fine. As we've seen, it's not much more complicated than that, than pushing different data into the history. However, in real life, we know for sure that there are more than one method or two methods in this case for changing the states. There could be one for deleting, for appending, for adding comments, for changing some visibility options, and then we can think of even multiple classes. One is for articles, the other one could be for user comments, for uploading files, images, a newsletter, and something like that, that we want a history of to track. So if we are going to duplicate these methods of pushing the history and maybe logging the data into each and every method, we can see how it will become really ugly real fast. We could mitigate this a bit by extracting this into other object, into other function, like a history object or maybe log object or something in between, and then just having one single method. But then we are going to always think about dependencies between all involved objects. And again, there is still quite a lot to copy and paste this code and then maintain it. And we see how that becomes a bit difficult to work with if the same code is being repeated. So there has to be a better way. But I want you to think about how would you solve this problem of adding a side effect to a specific action without too much duplication of code like we've done here in this method. And then later I will show you one way of solving this using the command pattern. Let's now look at one theoretical problem and the solution that the command pattern solves. Here I am acting as a business owner with an e-commerce website. So on the admin page, there are three components presented to me: the inventory, orders, and the tickets. And each of these components has some communication with the backend, here presented with a white square box. Now, this is nothing special, it's just a regular page, right? However, each component has its own challenges. The inventory needs to always be kept in sync, meaning that while I'm looking at the dashboard, I want to see live how many products I do have in stock. I don't need to refresh the page every minute or every 5 minutes to see if I'm going low on some products maybe. The list of orders at the same time also needs to be in sync, and I want to be able to select few of those orders at the same time and mark them as approved while I'm maybe approving, or maybe I want to mark them as packaged while I'm marking and packaging actual products. And finally, I have a tickets component on that very same page, on the same dashboard, where I want to see and maybe reply to the individual ticket while I'm looking at this dashboard. So the inventory needs to have live status, which means that it somehow needs to fetch new information from the backend, let's say every 10 seconds. So the synchronization here is very important for this component. For order, if I need to approve 10 orders at a time, it's important that it handles that bulk processing confidently, so it doesn't stop in the middle, or I don't mark something as processed, but then for some reason the internet was bad or the server could not accept that request and something happens with one of my orders not being marked properly. There could be a database glitch or internet being unstable, maybe I'm sitting in a bus or something else will happen and the backend might reject only 1 out of 10 orders. That's obviously a problem for me, because I would have to cancel update on all of them, or I would have to refresh the page or refresh the status from the database, etc. You might think, well, there is nothing wrong with refreshing the page once in a while. You would be right, but we want to improve our skills at least here and to create not just good applications, but great applications. But this tickets component is something that a lot of people, and me in particular, would sit in a city train or in a bus and respond to tickets sitting at the airport, replying to my customers as soon as possible. And as I am about to submit the response, we go into a tunnel and I get offline and then I lose that response somewhere in the writing. I might get a notification, try again, but it doesn't work, and I need to somehow have that action remembered, that I have submitted the ticket or I have resolved the ticket or I have replied to it. And I want this application to have the ability to remember those tickets, those replies, and to repeat this action once I get online, without me having to look at the stars and finding when there is a signal and having to maybe refresh the page and lose everything. So how can we tackle all these requirements that we might have in our application? Well, surprise, obviously we're going to use the command pattern in this module. And what we're going to do is add additional objects to the actions themselves. So separating the action from the module, from the component. And this way our component only needs to call the action that's being done on the UI side in this case. And the action itself is something that we will manipulate. In the first case of inventory, we can just repeat the same action every 10 seconds or maybe 5 minutes
where we are just going to sync our products by just calling this action, right? In the second case, for bulk processing the orders, we can store multiple actions here in the local memory and local in the browser, and just make sure that each and every one of these actions is executed until the backend confirms that each and one of them is accepted. So that if there is an error, the action itself, the app itself will continue doing that action until it's through, until it works just fine. Or maybe application comes online. And the same goes for the tickets. If the internet goes offline, we can just cache the action in the local storage, and then when the internet is back on, when the browser receives from your phone or your PC that it's online, we can just call all the actions that were executed while the application has been offline. All this without having to do anything inside or with our components. Our components are just going to do whatever they were doing before. And we will have example of this in the skill builder part that's similar to this, with delaying actions, with delaying execution of an action. So make sure to not skip the skill builder part. So these are the main benefits of command pattern. But there are a few more as well. If there are multiple people working on the same order, or working on the same inventory maybe, or replying to the same tickets, we can store that actions and then log the history of execution. Maybe inform the user that another user has already been working on this action, or that the action has been done, and now maybe the state has changed for this. We have the state module as well, the state design pattern in this course as well. So make sure to look at that module. But that is how basically Google Documents, for example, work when you're collaborating with somebody. We can actually see their cursor and their actions and what they've been doing replicated in our frontend as well. This is probably what Notion does the same, Trello. So if multiple people are writing the same document, we can see their action there. Or every time you change something and then you hit undo method, you are actually doing the revert operation on the action. It allows us to change the state back to what it was before. And this is great if we need an action to be repeated, cached, manipulated in any way, without complicating each and every individual component of our application, like how to do undo, how to cache data, how to behave if it's offline, and things like that. So by the nature of this solution, the actions become more complex object, and that's one of the trade-offs of this design pattern. You could think of these actions as one additional layer in our application where our components would communicate with some other components, or to the backend, or maybe to some other services via this additional layer of actions here that we have sitting in the middle. All that is possible by separating actions into a separated entity and not being mixed with other state components and objects. Let's see how we can use the command pattern to solve our problem from before, where we are supposed to add history into the save article method and other methods, and even maybe change the state here without actually writing this code inside any of these methods here. In previous lesson, we've used another object called action, so we will obviously start by making another object here named article command. This is actually the class, not an object. And in the constructor, we are going to pass the actual article. We know that this is tightly coupled to the article because it's even in the name, it says the article here. We're going to store this, and we are going to make one method named change state. In it, we are going to track the new state and also the user who has done the state change. Here, we are basically going to put this history push and even this console log here. So now this is basically the same. This history obviously needs a place where it's going to store this history. I'll just make it an array here. And this state now needs to be new state that's been passed in. I'm going to change this state to the new state. And we can even add by user plus user. And this is the side effect of actually changing the state. What we need to do now is to call this article and then actually change its state to the new state. So this article command is a kind of a wrapper around the actual article, but it has some side effects, in this case like pushing to history and logging. So now here at the bottom, instead of calling the article change state, we are going to make one object called article command. And instead of calling the article change state, we are going to call the article command change state to review. And this is also by Alice, like our previous example. And then we're going to change it to publish by Bob, who is the only one senior editor that we have, who needs to approve all articles. When we go back to our console, there is type error. We cannot find the property of undefined. That is because we actually need to pass in the article to the new state in the constructor like this. If we try again, we can see now that the state has been changed and the history has been stored as well. So there is one save article with new text. And now if we log our article command history now, because we have moved the history from article itself to the command, we can see that there is a history as well here in our change log of state being changed from review to publish. And this is pretty much it. This is the simplest implementation of the command pattern. So what we've done here now, instead of directly calling the change state in the article, we are wrapping that with the article command. And the reason we are doing that is because then this change does not need to care about all the side effects that are going to happen. So we can do the same for this save article, just to prove the point that when we save article, we can then do some side effects on it. So here I will make one method. Let's call this save. And this save will just take in new content so that we can just push the new state just like we did before. So we are pushing to this article content, we are pushing the new content with the old content as well inside the history. We are console logging that the article has been saved. But then finally we need to call this article and actually update the article with the new content. So we are just intercepting the save article in a way, but we are adding more logic to it. This looks like a decorator, but this article command is clearly a different type of object, so it's not decorating the original article. So if I would to now save this article, not using the article itself, but actually by calling the article command by saying save, and the new article is, I can just say new text here, as we did before. We could pass in the user, like we did in our previous example, to be Bob. Let me just move this down here. So if we run this now, we can see that the state has been changed 2 times and the article has been saved. And in the history, we can see the same thing, that the state has been changed to review by Alice and then published by Bob. And then there is a new text here. So the history, the change log here exists, and it could be used for some other purposes. However, if we look now at our article, it does not care about anything that has with state to do and with history and with logging and with anything else. By using the command, we have actually separated the actual action of changing state and saving article, where the article now cares only about one thing, and that is working with actual article data, right? It does not care about the history state or console logging or user privileges or whatnot. So that when we call this command change state, we are actually going to do a few things in addition. We are going to store this to the history like we have here. So there is a history being maintained. We are also going to log this, and only then we are going to ask the article to actually update its state. Then this article will just do what it does. It will store this to the database and send this to the backend and save this to the article and things like that. And we have thus solved our history version and logging to the save article task without the article even knowing about it. We have in the history here the state where there is an old content which was undefined, but then there is a new content with new text, and we can see who has changed the states here from review to publish and things like that. And now you could do this even more complex, where in the action you could have, instead of just a property history here, you could have the actual object maintaining that history and receiving that history, or you could maybe just having a database at some point where you're going to send this data to be stored securely so that you have the history of all the changes. And I know what you might be thinking. We have just moved the duplication and these lines of history pushing to a different object. So what's the point? Well, you are correct. We moved the duplication to a different object. Here we would usually have a parent class, let's call it named action or a command, which would have its own log action methods, or as I mentioned, maybe different objects for handling the history. But we could use inheritance here on the article command only, so that we don't have to pollute the main article, and then gain access to the much more code, much more functionality here, because these methods could as well be in different classes. We could have something much more complex. I'm gonna paste it here to save time. But here we have the master class action and its log action here. Then we could have the change article state command, which will then execute this log action and do some other things like update the article. We could have a new method, a new object like save article command, which would then do several things on its own. But I will just comment this one out because this is a bit more advanced code. And I will leave it here for you to try on your own. But for this course, let's keep this simple with just two methods in one action. And let's go over it one more time to just recap what have we done now here. So we have made one article command. And now instead of calling article change state and article save state, where we are asking from article to keep track of its own state in addition to working with its data, right? We're kind of polluting article and we are breaking the single responsibility principle because article now has suddenly to think about many other things. We have extracted that into the article command object. And this article command has basically, well, in a sense, single responsibility principle, because it's caring about the action of changing the state and it's calling all dependencies, all things that needs to happen when the state changes, and also updates it and also asks the article to change its state, and then the same for saving the article. And the article itself only cares about, we don't even need this history, it only cares about its own data, its own state here. So what we have done is we have actually separated the actual action from the main object that contains the data. Now this action, as we've seen here, has some side effects like logging, like history. It could as well have delayed execution. It could have security checks. It could store this locally and then call this offline, or sorry, store this locally if your application is offline, but then it could fire it up when the application comes online. It could also do the undo functionality here because we have the old content here and we have the new content. And if we would to make an undo method here, we could just update the article back to its previous state. So it would have a rollback functionality, but it could also have a batching functionality, meaning that here we could update 10 articles once, and it could have many more additional functionalities that are specific to one action but have probably nothing to do with the article itself. If the article would need to take care of offline support, of history, of security and all things like that, you see how quickly that would become too difficult to maintain. We can now use this for caching as well if we are retrieving one article for database, so that we can have an action called load, and it could just check the local state and local data, and it could just avoid asking server completely if it sees that you have already asked for the article several times in past minute or two. It could even retrieve the article from its local memory if your application went offline, and here in the save article there could be a check if your application is actually online. If it's offline, it could just save this and start triggering every 5 minutes maybe to retry, or maybe it could call this action save again,
once your application gets online. So by separating the action from the information entities, we can do a lot more functionality without messing up and polluting our main object and making our job difficult. Let's try and find this design pattern in some real-life projects on the interweb. First example I here have is this very popular WYSIWYG editor, and WYSIWYG stands for what you see is what you get. It's called the CK editor. And this one actually brings a lot of memories because I was using it for I think about 20 years now, when it was still called the FCK editor. So good old times when JavaScript was something we used to load the jQuery with. Anyway, CK editor also uses command pattern here, and they even have a wiki page explaining how to use commands. And these commands are something that is used for us to extend the functionality of this editor, so that we can maybe handle state if there is refresh of this editor, or we could do some add commands on the execute. And there is many other places where the commands are being used. And this is basically used by all plugins. They have even a tutorial on how to make plugins that are going to write our own extension or plugin to do something specific by sending the, you guessed it, a command to the editor, to the main editor that they have. And what to do with it, here you can just add a highlight function to the code. And then you also need to refresh, and then you need to, register it and execute it and so on. Here it makes sense to use commands because it allows us to make plugins extremely easy, because all our plugins are doing is sending a command to the main editor, so that when the editor updates, where the source file of it updates, we don't need to change anything as long as those commands are still supported in the new version, and everything will work just fine. So you can think you could have an additional button for, say, doing the formatting of a selection. Maybe you want to highlight some text and make it bold. You could just make your plugin to send that command to the editor. The second example here that we have is actually a school example of using the command that I've mentioned several times, and that is the library to make undo and redo functionality. It's a bit older library. Here we can see the main use of this class, and that is basically using the command pattern. We need to use this JS undo redo and then set the state to it, and it will help us change the state, but also do the undo and redo, because we have the entire history in memory. So this works because our library can then just do the undo and redo on any value and keep the track of the history for us, so that we can focus on the business logic. They even have the more advanced examples here where they can do a lot of changes on the state itself. So you can just execute the lambda expression on the entire state if you wish. But the main purpose is, basically doing the undo and redo, because each action is being stored separately. It's very easy to use and helps a lot when dealing with some historical values, and commands act here as a way of communicating or a way of navigating back and forward in time. My third example is this Marionette.js from Backbone. It's actually an interesting library. It's also a bit older, but this is a collection of design pattern and implementation of design patterns all in one. This was popular back in time, before bigger frameworks were available. But among these design patterns, there are commands which allow us to make an application level commands execution system, and allows our components in our application to basically state that some work needs to be done, to send a command, right? But without be explicitly coupled to the component that is performing the work. And that's what we were talking in this course so far, right? They have here some handlers like foo and bar, which I really hate examples like that, with foos and buzz and cars and pizzas. But anyway, here we can register a command and set the handler for it, which would then be executed later. And why would you want to do this? Sometimes we want to add or limit commands dynamically maybe, and call them from database or configuration file or local storage. And we need to be able to call a function that will
Well, register some command or unregister some command and then execute it dynamically so that we don't have to write that in code. And once we have registered, then we can execute it somehow, right? It could be executed by time delay, by a script, by a online, offline event, just like we will do maybe in the skill builder lesson later. There we're gonna work with time execution, where events will happen at a certain time with a timeout, but you can obviously see how this could be used when application goes online or offline, or maybe in a specific interval, etc. And pretty much all cases we discussed so far in the course are also possible here with Marionette.
Let's summarize the command pattern before we go into the skill builder exercise to learn hands-on. Do you remember what command pattern does? It separates something from something, what from what. It separates an action or a command from the sender and the receiver. And this is very useful, and as it allows us to manipulate that action, that command itself in some creative ways. Why do we need to separate an action? We might want to put the action on a timer. We might call one action multiple times, so times over time. We can also store action somewhere, and do you remember what we can do with it? We can call it later again, right? So if our application goes offline, we can just remember the action, and when the app comes back online, we can trigger the action again. We can have actions also do a bit more complex things, like maybe revert a functionality. We can call actions as well in batches, like sending multiple actions at the same time, and several other examples. We went over several examples of delayed execution or scheduling, also rolling back the action if a complex application fails. We can also log the application, keep the history of who did what, even when, and if possible, we can restore the action, just do an undo of an action. And in the skill builder module, we will build delayed execution to practice this design pattern. Now, the command pattern gives us a lot of flexibility and benefits, and it also improves our code because our object now have single responsibility principle. They follow the single responsibility principle a bit better. Our object just calls the action and do not care about handling it. And do you remember some of the benefits, some of the pros that we talked about? One of the biggest benefits for me is definitely flexibility. We can call our actions both from different places and maybe at different times and from different sources. Second, it allows us for the batch operations and the undo functionality, basically a history of changes. And this is de facto design pattern if you need this kind of functionality. It also decouples our objects that are invoking the operation from the objects that are actually performing that operation. And this one could be both benefit and a trade. And that is that it makes all applications, all actions in the application uniform. So it's easy. It can easily make it easy to work with your application because you know what to expect. Everything is uniform, right? But it might start limiting you because actions could be a bit too rigid if they are not set up properly for your use case. Which brings us to some of the trade-offs, like my favorite, and that is the complexity. We are here introducing another layer of abstraction, so we need to make sure that this is actually something we need in our application. So don't just use actions because you saw it on the internet. The second trade-off is, well, the overhead, and that relates to the complexity part. We can suddenly have many objects with multiple lines of code doing an action, right? So instead of using one line of code to do action, we might have 20 or 30. And sometimes that's not an issue if it solves the problem that we are working with, but sometimes it's just not worth it. So it's good to know when to use it and how. Also, it is a bit difficult to follow the code. We need to understand the flow, and we need to understand how actions are working and to be comfortable with debugging them, with following them, because we will most likely not follow the code directly line by line, by following different actions and then reactions to those actions, right? So we need to keep a lot of things in our head in order to debug it. But the main use of the command pattern is to separate command from the sender.